other side.
Okay,
Is it each?
related rates are word problems.
I get that case too.
We're not doing that now. right?
Oh,
I'm
I'm
sorry.
sorry.
No, we're doing
No,
it.
no.
Okay.
So you're here.
So this is the study of what happens over time. I know, we're just doing notes, so you don't need your computers. So now, from now on, we are going to be finding the derivative. We're differentiating with respect to t instead of x. That means every single variable is now a function because it's a function of time. So when we did, like, if we had y, and we found the derivative, we said it was y prime or dy over dx, right? When we found x, the derivative was just 1 because it would be dx over dx. Now, what we're doing is finding, if I find the derivative of y, it becomes dy over dt. When I find the derivative of x now, it becomes dx over dt.
Just because it's a word problem?
Because now it's with respect to times instead of x. Okay, so you will be doing chain rule for every single variable. All right, so for example, the rate of change in area, we would write as dA over dt.
Wait, what is that? D, oh, D.
D blank,
Blank.
so whatever your variable is,
Okay.
goes in there.
So is T like saying rate?
T is time. So they're all rates because it's a rate of change with respect to time. Rates can be positive or negative. If something is getting bigger, the rate is positive. If something's getting smaller, the rate is negative. So we're going to take this in baby steps. The first thing we're going to do is translate sentences into calculus notation. Then we're going to take formulas and find the derivative with respect to t. And then we're going to put it all together for word problems. All right, so this first one, the volume of a cylinder is increasing at a rate of 6 cubic feet per second. So I'm using, for volume, I'm using the variable v. So it is a rate. So I'm going to change it to dv over dt. The rate of change in volume with respect to time is equal to 6 cubic feet per second.
Oh, that's like just for the.
That's it. We're just changing it into notation. Okay, so depth of water, I'm going to call that h, like the height of the water.
Does it matter what variable we're using?
No, usually it's volume V or A for area. If other than that, you would have to assign your variable in a letter or in the
Like you have to
picture.
actually write it out.
Or draw a picture with your variables. All right, so the depth of water is decreasing at a rate. So we're going to say dH over dt is decreasing, so my rate is negative 2 inches per hour. All right, at rush hour, the number of vehicles. The number of vehicles, so maybe let's call the number of vehicles N for number, is increasing at a rate. So again, it's a rate of change. So dN over dt is equal to 85 vehicles per hour. All right, this is weird. Okay, the next one says air is escaping from a spherical balloon at a rate of 15 cubic centimeters per second. So they're not really defining a variable here, but you should be able to tell what the variable is by the units. What do we measure cubic centimeters? Volume. So this right here tells me that it's volume. So that rate is the rate of change in volume. So dV over dt is equal to, if air is escaping, so is the volume getting smaller or bigger? Smaller, so negative 15 cubic centimeters per second.
I'm assuming we'll get points off if we don't put the notation. That is-
So you want to get in the habit of showing, because sometimes on FRQs, if you write that, you earn a point for it. Just being able to take the words and putting it in calculus notation. The other thing in FRQs is when you take a derivative with problems like this with respect to time, a lot of times it's 2 points for doing the correct derivative. That's 2 out of 9. That's a lot of points when you're talking about an FRQ. All right, so now what we're gonna do is we're gonna take these formulas that you should be familiar with, and we're gonna find the derivative with respect to time.
All
right. So we have to go over some of these formulas.
Area.
Hopefully not area of a triangle. Area of a triangle, I'm gonna use length times width. Oh, sorry. Area of a rectangle, sorry. I said triangle. Area of a rectangle is length times width. So now length and width are both functions. So
Oh,
when you find the derivative, we're gonna have to do product rule and you're gonna have to chain on. So dA over dt, that is the rate of change in area, is equal to the length times the rate of change in the width plus the rate of change in the length times the width. So what I'm doing there is product rules. So that is a function and that is a function.
mhm.
So I keep it, I take the derivative of the second plus the derivative of the first times the second.
And then there's simplify.
And we don't have to simplify, we're just finding the derivatives. Yep.
So, wait, why did we?
We chain on because now everything's a function of time. So this means I have a rectangle and my rectangle is growing. So the width and the length are changing over time. Okay, all right, circumference of a circle is 2 pi r, or you can say that circumference is pi times diameter. So rate of change in circumference, so dc over dt. 2 pi is a constant. So I am doing a constant times a function. So you just take the constant and you multiply it by the derivative of the radius, which would be dr over dt. If it was pi d, you'd have the rate of change in circumference, so dc over dt is equal to pi times dv over dt.
But they take either of those?
Either, yeah, and it could be in our word problem, if you're given diameter instead of radius, you might want to use that formula. Yes,
So
I not like one.
but pi is a constant,
Yeah.
so you're doing the constant times the derivative of the function.
Oh.
Like, just like when we did the derivative of 4x squared, it became 8x. Yep. All right, volume of a cube. Volume of a cube is just the side cubed. So derivative would be dv over dt. We bring the 3 down, subtract 1, but then chain on the rate of change of s. Right, so you're chaining on because the side is changing over time.
so you're always gonna chain on.
You are always going to chain on for every single variable you find the derivative of. Lateral area of a cylinder is around the outside. It doesn't include the top and bottom. Anyone remember? So I'm going to call that surface area SA or surface area.
Solid times.
It's circumference
Times off.
times the height. So 2 pi r times h. You're gonna need to remember some of these. For your test, yeah.
What is it?
All right, so now the derivative, when they give me two letters like that, when I find the derivative, I'm just gonna put it in parentheses. So the derivative of surface area with respect to time. Uh-oh, I have a function times another function.
So the
So
constant time,
product rule, so it's constant times
do we have to,
product rule. Now, the way I like to do it is I attach 2 pi to the r. So I think of it as this is one function and then the h is a separate function. You don't have to do it that way. I'll show you both ways. But the way I like to do it is a, so I keep 2 pi r times the derivative of h with respect to time plus the derivative of 2 pi r, which is 2 pi dr over dt times h. Or you can put the 2 pi in outside of parentheses and just treat like r and h as functions. So this would be r times dh over dt plus dr over dt times h, which is basically the same thing, but the 2 pi distributed or factored out.
This is like the setup.
This is the setup for the word problem. What's the difference? It's personal preference. I don't know why, I just like to attach it to one of the functions and treat it like a constant times that function, but last period, a lot of people liked it factored out like that.
We take like a brain break, it's just.
We might be able to take a brain break.
and they put cups on it. Perfect being the
All right, circle,
Like this comes.
area of a circle.
Do you have more candy?
Area of a circle is pi r squared. So derivative,
Helps my brain like have breaks, you know?
dA over dt, 2 pi r times dr over dt. You are chaining on the rate of change in radius.
So the two,
2 is from the exponent, bring the exponent down, subtract 1 from the power. And r is not like, just like when we did implicit, we put a y prime.
Yeah.
We can no longer write it as y prime or r prime because it's with respect to time instead of,
So
I love
is there like four problems where it won't say respect to time? Or is it this?
that we always.
the rates you're given are always like feet per second, or so it's always the time. Perimeter of a square is just 4 times the size.
Oh,
That just looks like. Oh. Shape of the yield.
So the P over dt is just 4, the S over dt. Are we getting the hang of this a little bit?
Oh, we're wide until we see a cylinder that comes.
Yeah.
no, it's like 1/3 something.
2L plus 2W, that would be a rectangle on a square.
What's the one?
They're all the
That's
same, so we make it 4. All right, volume of a cylinder is 1,
Oh, no, that's.
oh, not a, that's a cone.
That's from, yeah.
Cylinder
Base times.
is pi r squared h,
Sorry.
and then we have to do a product rule. So dV over dt, again, I'm gonna attach the pi to the r squared. So pi r squared dh over dt plus 2 pi r dr over dt times h.
Oh,
All right, I'm gonna tell you in case you forgot volume of a cone. 1/3 pi r squared h. And volume of a sphere is 4/3 pi r cubed. And I hope we all know Pythagorean theorem, a squared plus b squared equals c squared.
So you throw the quadrant.
I want you to try those three. Find the derivative real fast of all three of those. Cylinder, I had to do product rule again. So this is A and then times B. You could, yes, you're,
I think, I'm not sure.
well, if you distribute the pi, you should get this answer. So it would just be r squared dh over dt plus 2r dr over dt.
And it.
Let's go.
Yep,
This second week of it, you just write 2R.
yes, you can, yeah, the d, yes, I just do it in order.
It's right.
So that goes.
It's just one, so you should get it. One says, but I can't supposed to like do it now.
Yeah, I would.
Boom.
But how do you hear mom?
For the sphere, I went ahead and simplified it.
Oh my gosh.
Oh, I'm right.
I went very curious. No, 6 and 7%.
Okay, take a minute to check to make sure you got those correct.
You guys have the.
Again, if you left the 1/3 pi out in front, if you distribute the 1/3 pi, you should get my answer. Questions on those three?
Can you explain why we're changing it? Like,
Why we're changing it is because when we're given these word problems, everything is now a function of time, which means like y was a function, but x wasn't a function. X was just a variable.
well, we're already putting A, so that's already the.
I'm not sure trying to play.
But when we found the derivative of, like, if we found the derivative of y squared, we made it 2y times y prime, or 2y dy over dx, right? So we're chaining on, now everything gets a chain because everything's a function, just like y was a function, okay?
You have to.
Yes,
I know, 14.
14, yep. So 14, Pythagorean theorem, a squared plus b squared equals c squared. So I bring the 2 down, so 2a, but then times dA over dt. Same thing for b, 2b times,
Oh.
and we can't write them as a prime. We can't write them as a prime and b prime because it's not with respect to x anymore.
Why didn't you like square maybe spot C's like simple?
You mean square root? If I square rooted the whole thing, then finding the derivative of that is gonna be way harder. Because we'd have to do it to the 1/2 power. Okay. All right, now trig functions. Yes. That's an abbreviation for Fredonia, which is where I went to college.
Bro, that was the question.
All right,
Oh, no.
trig functions.
Yeah, whenever I see a topic, I'm like,
All right, I'm just gonna pretend, I wanna put in constants here. So if I have a triangle a right triangle, and I'm using theta, I'm doing SOHCAHTOA, okay? So sine of theta is opposite over hypotenuse, okay? So I'm just pretending that the hypotenuse is 5. So if I find the derivative, what is the derivative of sine?
Cosine.
Cosine theta, but theta could change over time. The angle could change over time, so we have to chain on d theta over dt.
Okay, and then,
And then the derivative of x over 5 is just 1/5 times dx over dt.
Wait, I thought you said we don't do that to X.
No, now everything's a function, including x.
So why did we make it 1 then?
you didn't make it 1, you're multiplying 1/5 times x.
This x over 5 is the same thing as 1/5 x.
Yeah, that's.
All right, another popular function we use is cosine. So cosine is adjacent, so I'm gonna use A. Adjacent over hypotenuse, so I'm gonna call the hypotenuse 5 again.
Why did you use x?
I used A for adjacent, I don't know what, oh, I used X instead of O for opposite, because O looks like 0.
That's cool.
Yes.
Little birdie told me we could take this exam 5 times. That's right.
No. Derivative of cosine is negative sine theta times d theta over dt equals, again, A over 5 is the same thing as 1/5 A. So it's gonna be 1/5 times dA over dt.
First time's always good these days.
And the last trig function that we use is tangent. Tangent is opposite over adjacent. So I'm gonna say x over 5. We're just making something up. Just so you understand how to find the derivative. Derivative of tangent, secant squared theta times d theta over dt equals 1/5 dx over dt. Yes.
Wait, why do we use theta?
Because every variable is now a function. So every variable gets a chain. So theta is a variable, so we're chaining on d theta over dt. The derivative of theta is 1 times d theta over dt. The derivative of x is 1 times dx over dt.
So why is this the theta?
Because secant is in, or theta is inside secant. Like, secant is nothing without theta inside of it. You cannot, if you have sine without theta, it turns into sin. All right. 1 minute mental break.
No. And in right, is kind of you on the influence for that 1 minute question mark, and look at your food
Because I'm recording and I'm sharing my screen.
Okay.
They can hear what you're saying.
I.
Don't take the slides.
Oh.
I'm just joking.
I was college student.
Watch the
I
video.
don't want you to listen. Don't. Ask your best friend.
What's
Yeah, I didn't know.
You have video. I think it'd be like.
Expired. So people could created a YouTube channel. And
Oh, you're going on some fun. All right, break's over.
Wait, what's the YouTube?
Ready?
I like this.
Okay, ready? Okay,
We're so good.
lock in, lock in. I'm sorry. Sorry. All right, so we teach these word problems, using this little chart to help you to organize your work.
Yay.
Do you have to use this chart?
Yes.
No. It is just a tool that might help some of you to organize your work so you don't forget a step. You do not need to do this. But what we like to do to organize our work is we make a plus sign and then we draw a picture in this corner.
Picture.
Down here, we list the rates and what I'm gonna call when values. And then next to our picture, we put the formula we're going to be using. And if possible, we want it in one variable.
Like not like X1.
Like the cylinder problems with radius and height, if we want to try to make it just height or just radius to avoid product rule. And then down here is where we differentiate. Oh God, did I spell it right? I don't know. You stopped me in the middle of writing it and,
Differentiate.
oh my God.
Well, that's on the video.
You find the derivative.
I didn't
There we
realize
go.
it here.
Okay. A few pointers. If something is a variable in the problem, you have to label it as a variable. So how do you know if something's a variable? If over time it's changing, it's a variable. If something remains constant over time, then you can label it as a constant. Do not plug in any rates or when values until after you find the derivative. So this little quadrant goes into that. You can never go across and put it into the original. If you see a second equation to reduce the number of variables prior to taking the derivative, do so. That avoids product rule. And if you don't remember to do that, then you might have to do some more work to get the answer. All right, here we go. Our first word problem.
Oh, it's so fun.
It'll cover.
I don't even know what cosine is.
Has anyone ever dropped a rock into a pond and you've seen circles form and form and form and they get bigger and bigger and bigger, right? That's what we're doing. So in my picture, instead of drawing like a bunch of circles like that, I'm just gonna draw one circle,
So,
okay? And over time, is the radius of that circle changing?
yeah.
Growing.
Yes, it's growing. So in my picture, I'm gonna put a little arrow to know that it's growing and I'm gonna label it with a variable r.
Why not the diameter so?
Because usually, like most of our formulas for have r instead of t. The radius is increasing at a rate. So what is that in calculus notation?
D of
dr over dt. The radius is changing at a rate of 1 foot per second. When the radius is 4, what is the rate in area? So what am I trying to find? I'm trying to find dA over dt
So it's just.
when the radius is what?
4.
4.
Or derivative.
Oh, no, that's foot feet. That's a symbol for feet, sorry.
Actually,
Do we not do that?
Or prime. No.
All right, so now the formula. What formula am I gonna use? Well, I'm looking at the letters and the rates that they give me. I want to find dA over dt. So what, so I'm gonna use area of a circle. Okay, that's already one variable, so I don't have to do anything else. So now I can go down to here and find the derivative. So we already practiced that, so dA over dt is 2 pi r dr over dt. Now we can plug in our rates and our when values. So by when values, I mean the radius of that circle in the water is not always 4. It changes over time, but I'm like freezing time when the radius is 4 and finding the change in area. So I'm looking for dA over dt. 2 pi when r is 4. And the r over dt was 1. So 8 pi. So dA over dt is 8 pi. And then let's think about our units. Area. How do we measure area? Squared unit. So it's going to be feet squared per second. So area is here over time, which is seconds. And that's our answer. Yes. Right here. Because they told us the radius is increasing at a constant rate.
You're
So
expired.
remember how we practiced changing the sentences into calculus notation? So we're changing that sentence into calculus notation. It's the rate of change in radius, which is dr over dt. Yep.
We're gonna finish.
Okay, we're gonna finish.
Oh, yeah.
All right. Go ahead and get a head start. Draw yourself a picture. See if you can figure out any of the rates that they give you, any of the when values. You do not need to draw the picture. It is there as a helpful. You do not need to do this T chart. You can just list out the things. My sphere looks like a circle because I'm not drawing a sphere.
Oh, this is too. I don't.
Yes.
Okay, so find the rate of change in radius when the radius is 2 inches. So I'm finding dr over dt when r is 2 inches, but I'm a little stuck. I don't know what that 4.5 is. It's the rate of change in volume. How did you know that it was the rate of change in volume? Because it's cubic inches. So dV over dt is equal to 4.5. What formula am I going to use?
Your volume.
Volume of a sphere. And then we find the derivative, which we've already done. So dV over dt is 4 pi r squared r over dt. There are a lot of places.
That's why we.
Now, I can plug in the values of what's next to it. So dV over dt, I'm going to put in 4.5. 4 pi instead of r, I'm putting in 2. And I'm looking for dr over dt. Why did I do what? Somebody come out. So 4.5. 2 squared is 4, times 4 is 16.5. So divide by 16 pi. 16 pi is all in the denominator. So please be careful. If you are one of those people that write your division bars like that, you need parentheses around the 16 pi. I'm gonna write it as 4.5 over 16 pi. Oh, I didn't leave room for units. So 4.5 over 16 pi, what are my units? Inches per minute. So again, radius, we're finding dr over dt. What is the radius measured in is inches. They could simplify that. How could they simplify that? 4.5 is 9 over 2. So they could write it as 9 over 32 pi. Just in case, yep.
I said 4, not 1/3.
When you take the derivative here, the 3. Confused. I didn't do that.
I said 2.
When you take the derivative, the 3 comes down and cancels with that 3. Okay,
Oh, no.
Ladder?
Pythagorean theorem. That's like a good old logic. It's like math 3.
oh my gosh, now they're going crazy.
Another break, another.
That's the math 3 pleasure.
Especially since we're late.
So-
All right, we have a ladder resting against a wall.
Feel strong and actually-
All right, what is happening is the ladder is being pulled, the base of the ladder is being pulled away from the wall. So this is going in that direction. So this length right here, that blue line is changing over time.
It's
So-
increased.
And it is increasing, so I need to label it with a variable.
And
It's okay if you draw your ladder the other way. There, that green line, if you are pulling the ladder, the top of the ladder is gonna slide down the wall. So that green line is also going to change. So we need to label it with a variable, and I'm gonna call it Y. Now, the 26-foot ladder, over time, is it changing lengths? No.
Oh,
So
it looks
is
like
the
it's
ladder
dropping.
going from 26 feet to 24 feet to, no,
Yeah.
how?
They retract.
Does like,
ladders.
yeah.
See those?
Right?
Yeah. That's there. Very well.
Giant, little giant.
Put it on there.
I can label the ladder with 26 feet because it is not changing over time. It does not need a variable. Okay, so now that I have my picture labeled, I can write my rates in terms of my variables. So what is 4 feet per second? Which variable is 4 feet per second? Dx over dt. And that distance is growing, so it's gonna be positive. How fast is the top of the ladder sliding down the wall? So I'm looking for dy over dt when. What is
X
10?
equals 10.
When x is 10? All right, for these triangle problems with the when values, I like to redraw the triangle down here. So I'm gonna redraw and this is still 26. This is 10. And if I do Pythagorean theorem, you get 24. How did I do that so fast? It's because I know of Pythagorean triples. Like I know 5, 12, 13 is a Pythagorean triple. 5 squared plus 12 squared equals 13 squared. So if I change this 5 to a 10, this turns to 26 and that turns to 24. 3, 4, 5 is another Pythagorean triple. Never mind. All right, what formula am I gonna use? A Pythagorean theorem, because I just used it, right, to find, so I'm gonna be using a squared plus b squared equals c squared. But let's change it to match our picture. So instead of a, I'm gonna have x squared. Instead of b, I have y squared, and instead of c, I have 26 squared. I can put 26 in because it's constant. So now we find the derivative, so 2x, the x over dt, the rate of change in x, plus 2y times the rate of change in y, equals, what's the rate of change in the latter? 0, because it's not changing lengths. And now we can plug in. So 2x is 10. The x over dt is 4. To what is y? Down here, using these when values, at 24.
Oh, I'm looking for it.
24 came from a squared plus b squared equals c squared. Like, they told me when x was 10, so I added 10 to my picture and found the missing side. So I didn't know this value. So since I didn't know that value, I was looking at, I knew 26 and 10.
Okay.
So I did 10 squared plus y squared equals 26 squared. All right, so here I get 48
48 attached.
dy over dx. Yep, it is attached.
So you just divide it.
You have to divide it, but this I can subtract to the other side and get negative 80. Negative 10 over 6, which is negative 5 over 3. And my units, feet per second.
Three, two, one.
Another minute brain break.
Yeah.
Yes. I actually understand, so it's just I'm gonna do something wrong and
So tomorrow we do a little bit harder problems.
Okay.
And then Thursday we practice and Friday you practice in a group quiz.
Oh, wait, that here's my grade ups.
I think we should have a quiz on.
Your test. I get to pick my grade.
The circumference of a circle. And those equations, those formulas, like how can a derivative of formulas?
Then it's the.
It's
could be my grade.
Okay.
Okay, Miss Brown, you like that?
No.
Why are you not being? Hello, Chris.
My cousin.
Oh, that's exciting.
What's your graph?
That's all you. No, it's like, wait, who's our stuff?
You should wear white.
Okay, let's.
Oh, remember
Mr. Suzuki, have your stuff.
so bad.
All right, here we go. A conical tank means a tank in the shape of a cone.
Yeah, it's like English.
The point is down.
What?
All right, so I have a cone.
Can you explain how to draw?
It's a tank. I
I
draw a
It's a
V
circle
with
and
a
a
circle, like
Can you
an
not look
oval, and a triangle.
Concepts all.
Oh, my.
It is being, the cone is being filled with water at a rate of 2 cubic feet per minute. So what is this 2 cubic feet per minute? Volume. So dV over dt is 2 cubic feet per minute.
I have a question. Why did you put an arrow in there? Like, word?
Okay, water runs in. You want me to do this?
I just didn't know what you like.
Okay.
You even came there.
I didn't finish my picture. The height of the cone is 10 feet and the diameter is 10 feet. So that means that actual tank itself, is that changing size? No. So I can label the outside of my picture. I can label this is 10. And I can label the radius over here is 5. But as I fill it with water, as the water level rises, if you look down, the circle is getting bigger and the height of the water is changing. So I have to label this as H and that as R because those are changing over time. As you pour water into, so here I have my little cone. You know, you go to the doctor's office and you have these little paper cups that you fill with the water, right? So if you fill the water, the height of the water is changing. And if I look down, the circle is getting bigger as you fill it up. Right? But the actual paper cup itself is not changing. All right, what are we trying to find?
The rate at which the water levels are.
So in my picture, which variable?
On.
So. You're
Oh.
finding H.
Hi. Just kidding.
Water, the height of, so dH over dt,
When. H.
when
6 question.
H equals 6 feet.
It's just like so.
After we did the prime stuff, there's.
So what is the formula I'm gonna use?
Oh, 1/3 pi or something.
H.
Put me out that little water.
You forgot page.
All right, now here's the part that you're not gonna like. If I were to find the derivative of that, which we did, remember it was like, had a dr over dt and a dH over dt because we had to do product rule. They don't give me dr over dt.
Oh.
So that
Can't do
means
it.
I need this equation in terms of just H's. So lucky for you, a cone has similar triangles in it.
Oh.
Oh, no, yeah, no,
Yeah.
that's not.
Do you see this triangle here?
Wait, what?
Okay. And then do you see
But isn't that a
that
curve?
triangle?
How does that?
Not if you're going straight down the cone. So the big triangle here. This is 10 and this is 5.
We just got the highlighter.
The little triangle. This is H, this is R.
Okay.
They're both right triangles and all right triangles are similar. So I can set up proportions.
Oh my gosh. why
Oh
are
my
you-
gosh. I can say R is to H as 5 is to 10.
Picture box.
Sorry. So what is R equal to?
10.
Are equals to 10.
1/2 H.
Oh, you're multi.
Yeah.
Okay, 5 over 10 is 1/2, and then I multiply the H over. Why am I doing this? Because I want to get rid of that R and turn it into H's.
Okay.
Why do I want to turn it into H's and not R's?
Or variable.
And I'm looking for DH over DT.
I have a question.
Yep.
How'd you get R equals?
Proportion.
Yeah, but like, I noticed.
Okay, you want me to cross multiply and do it like you did, so 5H equals 10R. So R is equal to 1/2H. Okay, all right, so volume.
And that just be 1/4 squared.
So instead of R, I'm changing it to 1/2H, and now I have to simplify this before I find the derivative. You can't find the derivative with it looking like that. So 1/3 pi, 1/4 H squared times H. Which is what? 1/12 pi
What the?
H to the third. Now we're ready to find the derivative.
I have a question.
Yes,
Do you have to do it as like 1/2 H, or could you just do H over 2?
you can write it as H over 2, but
But like, would you have to still like either way take it out and multiply by the 1/3?
you still have to,
Okay.
yes, you still have to simplify it
Okay.
before finding the derivative. All right, dV over dt, bring the 3 down, so 3/12 pi H squared times dH over dt. Yes, you can reduce that to 1/4. I'm gonna do that in the next step. What is dV over dt? 2. I'm gonna change that to 1/4. What is H?
10.
No.
What did you guys say?
When,
Oh,
I was
I was looking at the proportion.
okay, so what's that? 6 squared is times 1/4, 9. So this is gonna be 2 over 9 pi. It is not 2/9 pi. It's 2 over 9 pi. 9 pi is in the bottom. What are my units?
Wait,
B per
No,
no.
no.
B per
Feet per minute. Why is it not feet cubed?
It's height.
Because it's height. Height is measured in feet, not cubic feet.
Marcia does that we all.
No one is paying attention?
So he's paying attention, I don't understand.
All right, you are gonna try number 6. Skip 5, try number 6 on your own. Another cone. Yes, you do know where to start. Try it.
I believe you guys.
Draw a picture.
God, great.
Sure.
Oh, that was all the fingers.
Stay
So that's gonna be
Okay, -1 over pi is what you should get. All right, so first of all, dV over dt is negative because the water is leaking out of the tank. Yes.
On the side, like, I don't get it's why we're reading the form.
Okay, so when you have a cone, like this 9 here,
Wait,
is from the tip to the center of that circle. That is 9. So you have a triangle. And then the water level creates another triangle because you're going to the center, you're going to the point.
That's the radius.
And this is the radius of the water.
Okay.
Yeah.
I actually understand.
All right, we have one last problem.
I got. I just. That would work. I just got.
It was.
All right, any other questions on that? All right, last one. Back up to example 5.
This one. So, right, look, I got that.
That was. Even those days.
I had heard.
A right
I beat you.
circular cylinder means it's a cylinder that's standing upright as opposed to the Leaning Tower of Pisa.
What?
Well, then
It's
that's-
not a regular cylinder?
Whoa, so circle, fine, circle.
It's just a regular cylinder. It's just mean it's not tilted. All right, the radius is decreasing, which means the cylinder is getting skinnier. And the height is increasing, which means the cylinder is getting taller. So both of those dimensions are changing. So I need to label them both with variables. So this I'm going to label with R. And then going straight down, I'm going to label with H. They are both changing. What rate is the 2? dr over dt, and is it positive or negative?
Negative.
Negative because it's decreasing. What about the 5?
Positive.
It's positive and it's dH over dt. And what am I trying to find? The rate of change in volume, so dV over dt. When R is 4 and H is 6.
This one. Reminded me of something.
Okay.
Oh,
Okay. We do not have triangles when we're talking about a cylinder. The only time you're gonna have similar triangles is if it's a cone. So anytime you have a cone, you're gonna be able to change it into one variable because you have proportions. A cylinder, we can't, it doesn't come to a point. But what formula, since I'm finding dV over dt, I'm gonna use the formula for volume. Okay, now, we can't eliminate a variable because there's not proportions in a cylinder. I also know that I can't eliminate variables because they gave me dr over dt and dH over dt. So because they gave me both rates, I know that I'm going to be doing product rule.
why can't you just, they gave us R and H.
Because they gave us R and H, so we don't need to eliminate a variable. No, we don't need to. So dV over dt, we're just going to do product rule. And then from here, we can plug in our when values. So we're looking for dB over dt, that stays a variable. Radius is 4. dH over dt is 5. R is 4.
What's your double H on that?
The R, because it's product rule. So we have
Oh,
to
yeah.
do.
Yep.
Sorry, R, what's the R over dt? -2, and what's H? 6.
Wait. Oh, wait.
Oh, Lord, somebody tell me what you get. 16 times 5 is what?
80.
80 pi minus
80 pounds.
24 times 4,
I got 80 plus.
96.
Yeah.
So -16 pi. 80 pi minus 96 pi is -16 pi. And what are my units? Cubic inches per second.
Oh, absolutely. Lots of. Right.
Call it a day, man.
Bye.